So, in this session, which is lecture 5, catering to unit 5, we will talk about what is data and how data is prepared for further analysis. So, as we all know that data is something that we get and that data is raw. Raw means it is not processed. And when the data is raw, it becomes very difficult to understand the data, to clean the data and prepare the data so that the right data goes for data analysis process and eventually data analytics. So mainly in this session, we will talk about how and what are the techniques that we will be using to prepare the data and finally visualize the data in the form of some very beautiful graphs. Let's have a look on the content that we will be discussing in this lecture. We will talk about factors, G-sub and sub-function, dealing with missing data, which is extremely important. What is an NA? The concept of NA. Way to locate missing data. Data filters, under which we will study which function for non-missing data. Data filters with is NA function for missing data. Removing records with missing data. Resetting the data frame index. Replacing missing data through factual analysis method, replacing missing data with median imputation method, and replacing missing data with deriving values method. After doing these many actions on the data and preparing the data, we will talk about visualizing results. Visualizing results basically means that how we will see the results on the screen. So, this lecture is very crucial as far as data preparation and finally data representation on the screen is concerned, and you will get a good insight on all the topics which are there in the content. Factors. What are factors? We have been talking about factors in our previous lectures also, but in this lecture we will talk about factors from the point of view of analysis. So we all know that factors in our programming language are data structures that are implemented to categorize the data or represent categorical data and store it on multiple levels. So mainly, the factors are the data structures which divide the data into various categories, or we can say into various stratas. They can be stored as integers with a corresponding label to every unique integer. Though factors may look similar to character vectors, they are also integers and care must be taken while using them as strings. The factor accepts only a restricted number of distinct values. So we all know that factors are basically the data structures where we are categorizing the data and we are storing the unique values or distinct values in a list of values. We all have seen that when we have to find out the distinct values, we go for factors, and from there we find out what are the basic categories, and then we can divide the data on the basis of certain categories. Let's talk about some attributes of factors in R language. Now, we all know that there is a variable x. What is x as far as factor is concerned? It is the vector that needs to be converted into a factor. So basically, if we say x, x is the series or it is the vector series which is finally converted into the unique factors which are there in the series. So we have to understand that whenever we are factorizing our data, we need to have a vector in advance on which we will do the factorization. Levels. It is a set of distinct values which are given to the input vector x. So sometimes we can give the levels in advance. We can set the levels in advance, and levels are the set of distinct values which are further given to the input vector x, and the vector is factorized on the basis of levels. Labels. It is a character vector corresponding to the number of labels. So basically, when we talk of labels, it is a character vector where there are many labels. Exclude. This will mention all the values you want to exclude. So sometimes we want to exclude certain values in a list. So we use the exclude attribute. So in that case, all the list of values which are mentioned after exclude will be excluded from the X vector. Ordered. This logical attribute decides whether the levels are ordered or not. Nmax. It will decide the upper limit of the maximum number of levels. So sometimes we have to give an upper limit to the maximum number of levels in the input vector X. So these are the basic attributes of vectors in our language. We have seen X, levels, labels, exclude, ordered, and Nmax. Definitely when we apply this in a program and see the output, it becomes easy for us to understand the concept of each and every attribute of vectors in our language. Now, let's understand how to create a vector in our programming language. The command used to create or modify a vector in our language is factor. So you can see a factor with a vector as input is used to create or modify a vector. There are two steps to create a factor. First, create a vector, and then convert the vector created into a vector using the vector function. So it is basically a two-step process to create a vector. So when I'm creating a vector, first of all, I have to create one vector, which is nothing but the list of values. And second is that I have to convert that vector into factors by passing the vector name into the factor function. So mainly the factor function, if I say factor and within brackets X, it means now I'm factorizing the values in the variable X. X is what? X is a vector. Let's have a look of this code snippet and understand certain things about factors. Here in this code, we are checking for a factor in R. The function isFactor is used to check whether the variable is a factor and returns true if it is a factor. So let's understand how it works. When I pass within the factor function a vector with the help of C function, I'm passing the list of gender, female, male, male and female. So female, male, male and female is the list of values which I'm passing as a vector into a vector and storing the factors in the gender. So I have created the factors, or I can say I have factorized my vector and I have stored the result into gender variable. Now, in the next line, I am checking whether gender is a factor or not. So how I will do it? I'll write print. Within brackets, I'll write is.factor, which is the function factor. So I'm calling the function is.factor, and within the factor function, I have passed gender variable. So gender variable is now tested for being a vector or not. So since the gender variable is storing the factor values, the output will be true. So isFactor function will check whether a variable is factor or not. If it is a factor, the function will return true. If it is not a factor, the function will return false. Function class. Function class is also used to check whether the variable is a factor, and if it's true, it returns factor. So basically, the class function is also there to check whether a variable is factor or not. In other words, either I use isFactor function or I use class function to find out whether the particular variable is a factor or not. The only difference is that isFactor function will return true or false, and here in the class function, it will give the output as factor word itself. So have a look of the code. Gender, factor, 3, female, male, male, female. So I have created a vector and that vector is passed into the vector. The final result is stored in gender, class gender, and within the class I have passed the gender variable, and the output is that the class of the variable gender is returned, which is a factor. So that is how we come to know that whether a particular function is factor or not. Let's understand how to access the elements of a factor in R. Sometimes we have to access the elements, and how to access that number or that particular value is also a tough task. So like we access elements of a vector, the same way we can also access the elements of a factor. If gender is a factor, then gender I would mean accessing the ith element in the factor. Now, let's have a particular example here where we have created a factor of the list into the variable gender. So you can see over here, if we write gender and within the square brackets I write 3, what will it return? So here you can see the output would be male because there are two factors. You can see over here female, male, male and female. So the gender is having the factorized values. So you can see the output would be male and the labels are female and male. So that is how we can find out the value. Now suppose more than one element can be accessed at a time, but how can we access that? If that is the question mark. So in that case, what we are doing over here in the example, we have taken the values as a vector which is passed into the factor variable, function, and the result is stored in gender. So you can see if I pass gender and then I pass a list with the help of C, I'm creating a vector of 2, 4. What does it mean? It means that the output is male and female. So you can see over here the second position is 2, which is male, and the fourth position is again female. So at the second position we have a factor male, and at the fourth position we have the factor female. You can see over here in the output, and the levels are female and male. So you can see explicitly I'm passing the positions, or I can say the indexes, and with the help of indexes I'm able to fetch the value. That is how I'm doing over here. Now in the next example you can see that we have again passed the factor into the gender, and I'm writing gender minus 3. So gender minus 3 means what? That we have to just suppress the value at the third location. So what we get the result? So suppressing the value at the third location, rest all values will be displayed on the screen. So you can see over here that in the output we have female, male and female. So you can see over here female, male, male, female. So it was one male is suppressed, which is basically suppressing the third location. So if I want to suppress a value, I will put a minus sign prior to the number, so that suppressing that number, rest all will be projected in the output. And then in the output you can see levels female, male, which means there are 2 levels. So that is how I can access more than one element at a time. And if I just want to access one element at a time, in that case I will just write gender, which is my factor variable, and within the brackets suppose I write 3, so I'll get a value at the third location. But if I want more than one value, then in that case I have to pass a vector, and within the vector I'll give the positions, the index positions, and from that index location, from the vector I'll get the values, whatever values are there. So I hope you all are able to understand concept of vector and how vectors are concept of factors, and how factors are created, and how factor values are accessed, and how we can use these values for some kind of processing. That is how we can do, and we can understand that later we will see there is something called as factor analysis, where we can apply certain good logics and do the analysis of the data on the basis of the factor values.